So what I thought I would talk about for us at Bruker, it's been a very busy year. Basically in this past year, we as an organization have launched four completely new mass spectrometry systems. We've made a number of improvements in all types of mass spectrometry, including MALDI, the ESI TOFs, our ion traps, and our FTMSs. Basically, unlike what you normally get, a lot of times in product improvements where you get incremental improvements, each one of these products represents really an exponential jump in performance of some characteristic of that particular mass spec, be it sensitivity, be it accuracy, be it speed. But basically, all of these are really revolutionary instruments. So if you're working in any type of area that involves any of these sorts of mass specs, if you've never heard of us or you've never paid attention to us, I recommend that you basically spend just a few minutes and you're going to find a lot of really interesting surprises. What I'm going to focus on today is primarily the instrument here, our new ultra-high resolution TOF that we call the Maxis. And basically this was an instrument that was designed to solve a real problem in mass spectrometry that's existed for years. And that was basically the problem of speed versus resolution. Essentially, the problem is shown really nicely on this graph, and that if you graph resolution or speed of all types of existing mass spectrometers here, what you find is you have to make a choice. So basically, you can have high resolution systems like FTMSs and Orbitraps and whatnot that work very, very well at very low speed. But the problem is, as soon as you increase the speed of the separation that you're working on, the resolution on those systems drops exponentially. Or you can play this game, where if you're going to do a fast separation and you need a fast reading, you can use a TOF. But the problem is the TOF doesn't have very high resolution. So for instance, if you're in, say, a DMPK group where you need resolution and you'd love to use a fast chromatography method to separate all those juicy metabolites, you've got a real problem. It's basically, as everyone found, you fire up your UHPLC, spend a lot of time validating a method, hook it up to your fanciest mass spectrometer, only to find you've got something that performs worse than a benchtop QTOF. So what we've done is we've conquered this problem with this new instrument that we call the Maxis. And basically what this instrument is capable of is it will get you 40 to 60,000 resolution with less than ppm mass accuracy in both MS and MS modes at up to 20 hertz speed. And we'll get it over a 50 to 20,000 M to Z range. And basically all these things put together are simultaneously achievable in the Maxis. And this is impossible with any other technology. There's no other system that can do this. But what we've also done is not only can we give you all this, but we've not sacrificed any of the sensitivity or dynamic range of a traditional QTOF instrument. And as I'll show you in a minute, this instrument is both small molecule and intact protein capable. So what we've been able to do are just simple things like this. This is a 30-second UHPLC separation of a number of different drug compounds. And basically what we're able to get here is all, again, sub-ppm mass accuracies. Average resolution here is around 50,000. But basically what we're doing is we can get now the kind of high performance and high resolution at this kind of speed that's previously been impossible. And what people have done is they've begun to start to take advantage of this. Just to show you another example, this is just an antibody, but now what we've done is just do an intact antibody and look at all the particular glycoforms of that particular antibody just directly on the Maxis. We can even do things like this to look at native proteins and even simple deamidated proteins, where you're looking at a difference in 1 Dalton on an intact protein. And you can easily pick this out with something like the Maxis. But to go on to the main topic, what I want to show is just a few examples of using the Maxis in a metabolite ID workflow. And basically there are a number of different software algorithms that we use to deliver the metabolite ID that you can come and talk to us about. But essentially it's a pretty standard workflow if you're used to doing metabolite ID, just now with a fast chromatography system and a different mass spec. And this is work that we did in conjunction with a customer who had a parent compound that basically he was doing some metabolite ID on in some plasma samples. And we just used the Maxis with his fast chromatography system.
Darwin, there's a message for you at the bar.
Oh, thank you. Almost done. Give me 1 minute. So basically, just to run through this very quickly, what I'll just show is just a couple of quick slides showing pre-dose, post-dose differences, all sorts of interesting chromatograms with metabolites ID down to less than sub-ppm mass accuracy, and some mass defect chromatography, mass defect work for those of you who like that stuff. Get more selective metabolites, they jump out. And last but not least, one of the things that we do very well is to set up, using some high-resolution extracted ion chromatograms, automated screens for metabolites when you're doing a metabolite ID project.
Thanks, Darwin.